All right. Um, Again, if you haven't checked in, you need to do that. So please do that if you haven't. Um, I get that people were struggling with R8 on the IXL. It went over some stuff that I didn't think it did. I kind of just looked at it and I didn't see that the directions like in fine print. Okay, so we're gonna go over that today, and I'm just gonna go over a couple of examples and how to answer it, and a little bit about where those come from, and then I'll give you the rest of the time to actually work. All right. So all these examples I'm going to take directly from IXL. Okay. So if you're having trouble with it, follow along, ask questions, uh, and that IXL and R7 will be due on Thursday instead of today. Okay. I'm not going to change the due date on it, but it will be due on Thursday. So I did send you an email with a little bit of guidance, and it had these top 9 values in a Word document, and then with some notes on it. All right. Um, and that's what we're going to be kind of talking about today. And before we do an example, I want to tell you a little bit where these values actually come from. Okay, so if we graph a circle, which I get that you don't know how to do yet, um, there are certain points that are important. Okay, so given certain angles, so 30, 45, and 60, we're not going to worry about anything over here, down here, or under. We're just going to be worrying about that first quadrant. Okay, so given these angles, those angles intercept a circle at different points. Okay, and the sine, so the sine of that angle will always give the y coordinate, the cosine of that angle will always give the x coordinate, and the tangent will give the ratio of the two. And you don't need to know this just yet. This is something that you will go over in Algebra 2 and again in pre-calc. But this is where they come from. They're not just random numbers. Sine of 30 doesn't just randomly mean 1/2. Instead, that's the height of this point right here. Okay, so that's the height of this side, which is the opposite side of our angle. All right, so sine will give the opposite over a hypotenuse, cosine will give the adjacent, and the tangent will give the ratio of the two. Okay, so that's where they're coming from. And there's a lot of information on this unit circle. Please don't worry about it right now. My point here is just so you understand that they are not just random values that are made up. Okay, they come from the circle, which is kind of the second half of trig. So right now we're worrying about the right triangle trig. This is the unit circle trig that where this all comes from. Okay, so if you don't understand this, don't panic. Just know that there are reasons why these values equal what they'd equal, and you will eventually go over that in Algebra 2 and pre-calc. Okay. So again, don't worry too much about this. I'm going to minimize this just a little bit. And then I want to go over an example. All right, so in IXL, you're given this diagram and you're asked to find RS. And it says in fine print to give the answer in simplified and rationalized form. Okay, so what I said is just take the trig function of this angle and then solve for the unknown. Okay, and we're kind of going to do that, except we're not going to use a calculator. We're going to use these top 9 values. All right, so again, kind of like what we've been doing, the first thing is to just see what we have and see what we need. All right, so what we need RS. So we need this side right here. Okay, and then we can label all the sides. So from our right angle, if we draw a line to the other side of the triangle, that's our hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite side. And then the remaining side is the adjacent. Okay, so we're trying to find the opposite side given this triangle. So then we can label what we have. We have some angle theta, which is equal to 45. We have our hypotenuse, which is 2 root 22. And then we need to find our opposite side. Okay, so then we need to find a trig function with opposite and hypotenuse. So if we remember SOHCAHTOA, we find opposite and hypotenuse, and that's attached to the trig function that we need to use. So we need to use sine here. So sine will always be the opposite side over the hypotenuse. And then really we just substitute in what we know. So we know the angle theta, that's 45. So sine of 45 is equal the opposite side, which we don't know, over the hypotenuse, which is 2 rad 22. Okay, so I want to pause there real quick. Are there any questions about what you see on your screen so far? Okay, now we need to do a little bit of groundwork in order to solve for the opposite side. So again, though, we can just start with substitution. So we have this sine of 45. And if we look up at the values that I gave you, we have that the sine of 45 is really equal to rad 2 over 2. So now we have rad 2 over 2 is equal to the opposite side over 2 rad 22. And again, we just need to solve for the opposite side. And we would do that by multiplying both sides by the denominator on the right-hand side. So we need, in order to get the opposite side by itself, we multiply by 2 rad 22 on both sides. One second. So when we do that, the 2 rad 22s on the right-hand side, they cancel, and we're just left with the opposite. And on the right-hand side, we need to multiply rad2 over 2 by 2 rad22. And what happens when you do that is you have 2 rad44 over 2. And then we need to simplify that, and if it comes to it, we need to rationalize it. Now, because there's no square root in the denominator, we shouldn't have to rationalize it. But to start, all we have to really worry about are those whole numbers first. And if we do that, you should be able to see that 2 over 2, that's just 1. So the opposite side is really just square root of 44. And then we can simplify that. So that's really, we can rewrite that as rad 4 times rad 11, which is 2 rad 11. And that's our opposite side. Okay, again, I want to pause there. I get that that last step can be confusing, but are there any questions over anything you see on your screen? How did you get 2 rad 44? So when we multiply both sides by 2 rad 22, we get 2 rad 22 times rad 2. Rad 2 times rad 22 is rad 44. And then 2 times that is just 2 rad 44. So you multiply everything underneath the square roots, and you leave everything else the same. So rad 22 times rad 2 is rad 44, and then 2 times that is 2 rad 44. All right, second example. Again, these are directly from IXL. I'm taking, like, I have my second screen is open on IXL. I'm just copying it down. This says to find TU given this triangle. Okay, and again, the first thing we do is we just determine what sides we have and what sides we need. Okay, so we are looking for this TU side. All right, and then we just label our sides. So the side opposite the right angle, that's the hypotenuse. The side opposite the angle we're talking about, that's the opposite side. And then the leftover side is the adjacent. Okay, so we're trying to find the opposite side of this triangle. So again, if we just label what we have, theta is 60, hypotenuse is 16, and we're trying to find the opposite side again. And the only trig function with both opposite and hypotenuse in it is the sine function. So if we set up our equation, sine of our angle will equal the opposite over the hypotenuse. And then we can just substitute in what we know. So theta is 60. The opposite side we still don't know, and the hypotenuse is 16. So again, I'll pause for a second. Are there any questions so far? Okay, now again, we can just take it in the next step further and substitute one more time. So down here we have sine of 60. So we find sine of 60 and just substitute in that value. So then we get rad 3 over 2 is equal to something over 16. And then we solve for the opposite side. In this case, it's easy. We just have to multiply both sides by 16 to get the opposite side by itself. 16 times rad 3 over 2 is just 16 rad 3 divided by 2. And then we can simplify that. 16 divided by 2 is just 8. So it's just 8 rad 3. And that's our answer. Questions about this problem? All right, so again, um, given this triangle, we're trying to find a certain side. First step is to just label what we have, label what we need. Okay, so what we're trying to find is BD, which is this side right here. We're given an angle of 30, and then we can label our sides. So the side on the other side of the triangle of the right angle, that's the hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite side. And the other leftover side, that's the adjacent. So we have the adjacent side and an angle, and we're trying to find the opposite side. So we need a trig function with both opposite and adjacent. So we'll be using tangent. All right, so we have theta is equal to 30. Adjacent is 28 rad 3. And the opposite side, we still don't know. So if we take the tangent of our angle, that's going to be equal to the opposite side over 28 rad 3. And I'll pause there for a second. Are there any questions so far? And from there, we can substitute one more time. So tan of 30, that is also equal to rad 3 over 3. And now we just need to solve for the opposite side. Again, in order to do that, we'll have to multiply by the denominator. So on both sides, we want to multiply by 28 rad 3. When we do that, we're left with just the opposite side. Then we have 28 rad 3 times rad 3 divided by 3. And now we just need to simplify, and if need be, we need to rationalize. Okay, so on the numerator, in the numerator, rad 3 times rad 3, that's just equal to 3. So we have 28 times 3 over 3. Those 3's can cancel, so the opposite side is just 28. Again, questions on this problem? once you get to about the smart score 75, you start to get things that look like this. All right. And when you have an angle that isn't 30, 60, or 45, then we start to have to use our calculator. All right. And the directions on this say to find PR. And then in fine print, kind of at the bottom, it says write your answer as an integer or as a decimal rounded to the nearest tenth. Okay. So again, those directions kind of cue you in to using a calculator. All right. And first we'll set up the equation, but after that, we'll go to Desmos, we'll go to our calculator, and we'll actually get an answer. Okay. So in this case, again, we always start off as normal. We want to find PR. So we want to find this side right here. And then we can label what we have and label what we need. So again, if we draw a line from our right angle to the other side, that's the hypotenuse. If we draw a line from our angle to the other side, that's our opposite. And then the remaining side is the adjacent. Okay, so we have the adjacent and an angle, and we're trying to find our opposite side. And the only trig function with that, with both opposite and adjacent, is the tangent one. All right, so we have theta is equal to 27, adjacent is 6, and then we're trying to find the opposite side. So when we set up our equation, we get tangent of theta is equal to opposite over adjacent. We can substitute in what we know. So tangent of 27 is equal to something over 6. And again, I'll pause there for a second. Are there any questions so far? Okay, now I'm going to tell you how I do it, and you can do this one of two ways. What I like to do is to get the opposite side by itself on paper first. That way we're not doing any mental math, we're not trying to do anything in our head. In order to get the opposite side by itself, we multiply both sides by 6. So the opposite side then is equal to 6 times the tangent of 27 degrees. And if you had that on a test, I would give you full credit for that. Okay, so you just being able to show me what's happening, that's worth everything. Now, in order to get an answer that IXL likes, we would get out our calculator, type in tangent of 27 times 6, and then we get an answer. Okay, and I'll show you how to do that on Desmos real quick. So if you don't have a calculator, you can go to Desmos, and then we just type in exactly what we have written. So 6 times tangent 27, and we want that to be in degrees. Okay, so right now this is in radians, and in order to do that, we go to our little wrench in the top right hand corner, click it, scroll down to degrees, click that, make sure it's highlighted, click off of it, and then we'll get our answer. Okay, and in IXL it says to round to the nearest tenth. So we get 3.05715 and so on. Okay, but we want just round it to the 10th. So this ends up being 3.1, and then we're done. On a calculator, so if you have a TI-84, all you would do is 6 and then multiply that by, and then tangent is a button, hit tangent, type in 27, and then hit enter. Okay. If you got that negative number that we saw before, that means it's in the wrong mode. Okay. So in order to change that, you'd go to mode on your calculator, scroll down to where it says radians and degrees, highlight degrees, hit enter, and then that'll fix it for you. Okay. I get that that calculator stuff is a little bit trickier, but this is actually exactly how I taught it to you last lecture. So that's just what you already know. But are there any questions about anything you've seen today or anything on your screen right now? All right. So I'm going to leave this open for the next minute or so. If you have more general questions, you can ask them here. If after a minute no one's asking anything, I will end this and then I will start a meeting on Teams and you can ask a little bit more specific stuff there. Okay, so I'll leave this open. Any general questions, go ahead and ask. Is the homework going to be finish R8? Yeah, if you haven't finished R7 or R8, get them done by Thursday. That's your homework. All right. So I will end this. I will start a meeting on Teams, and you can ask specific questions there. All right. Keep in mind that this is up. At least period one's lecture is up. But this is up usually pretty soon after. Okay. So if you're ever lost or anything like that, you can always go here as well. Okay. So I'm going to go and start a meeting on Teams. I'll end this, and I will see you there.